Hello, my dear children. So, these are the things that you have done in the last class, okay, about different types of levers, isn't it? Yes, class 1 lever, class 2 lever, and class 3 lever. And we have done the different terms which are related with levers, that is load, effort, and fulcrum. These are the things that this is the definition of lever, isn't it? These are the things that I taught you in the last class. All right, then we have learnt about the mechanical advantage and the principle of lever, isn't it? And the mechanical advantage depending on the position of the fulcrum, isn't it? Yes, and we also introduced ourselves with the class 1 lever, and I gave you two very important examples where the position of the fulcrum, if you all remember this from the last class, the position of the fulcrum, okay, tells you whether a lever is a speed multiplier or a force multiplier. Now here in this one we saw that the handle of this metal cutter is made longer to increase the effort arm, or the length of the effort arm is made longer by increasing the handle length of the handle, because you know that immense amount of force is required to cut the piece of metal sheet, isn't it? Metal sheet like काट्नु लागि त ज्यादा force चाहिन्छ. So that is why the handle is made longer so as to increase the effort arm, and in turn to make the mechanical advantage of the metal cutter greater than 1. So actually what you are trying to do, you are trying to make the mechanical advantage of the metal cutter more than 1, so that this lever turns as a force multiplier. So you need to understand in this way. Are you getting my point? Yes, because the position of effort, okay, the position of the fulcrum, whether it is near to the effort or near to the load, that decides whether the lever is, okay, force multiplier or a speed multiplier. All right, so today now we will discuss about class 2 lever. Class 2 lever. Now what is a class 2 lever? A class 2 lever is a lever where your load, okay, load lies between effort and fulcrum. So this is my load, fulcrum, this is my load, and this is my effort. Are you getting my point? Okay, so lever in which load lies between fulcrum and effort is called a class 2 lever. All right, now let's see about the effort arm. Now you know the distance from the fulcrum to the effort is called effort arm, and the distance from fulcrum to the load is called the load arm. So here wherever you may place this load, okay, whether you place near to the fulcrum or near to the effort, you will see that effort arm will always be greater than the load arm in class 2 lever. So here you know the mechanical advantage of lever is the ratio of effort arm to the load arm, isn't it? So here you see that load arm is always greater than effort arm, so you will get that mechanical advantage of class 2 lever is always greater than 1. So and you know that if the mechanical advantage of a lever is greater than 1, then that lever is what? FORCE, force multiplier. So you have to understand here that mechanical advantage of class 2 lever is always greater than 1, hence class 2 lever is always acting as a force multiplier. Examples can be a nutcracker, as I explained you in the last class or last video, isn't it? And wheelbarrow. You know what is a wheelbarrow? Okay, you can follow the picture on your book. And bottle opener, okay, or a bar which is used to lift the load. These are all the examples of class 2 levers. All right, and apart from mechanical advantage, you also must know about the velocity ratio. Now since mechanical advantage is greater than 1 here, so the velocity ratio of class 2 lever will also be greater than 1 here. Alright, so class 2 lever is always acting as a force multiplier. Why? This is your assignment. Okay. Alright, then let's move to the third class. Okay, that is class 3 levers. And you know, in class 3 levers, what is left? Fulcrum is used in class 1 lever. Load is used in class 2 lever. Now what is left? Effort. So effort lies in between load and fulcrum. So here, this is my fulcrum, this is my effort, this is my load. Okay, and you know how to define or how to explain class 3 lever now. So class 3 lever is a lever in which effort lies between load and fulcrum, and the distance from the fulcrum to the effort is called effort arm, and the distance from fulcrum to the load is called load arm. So here you see that load arm is always greater than effort arm. Okay, wherever you place the effort lie fulcrum ko nazik laijau, or you can take near to the load, but you see that always effort lies between load and fulcrum, and hence effort arm is always greater than load arm. So mechanical advantage is always smaller than 1 in class 3 lever. So class 3 lever acts as a speed multiplier. So what does it act as? A speed multiplier. So here, since mechanical advantage is less than 1, velocity ratio will also be less than 1 here in class 3 lever. Alright, so here this kind of lever is used to gain the speed, that is used to as a speed multiplier. Okay, examples are sugar tongs, fire tongs, knife, spade. Now what is spade? Spade is belcha. Okay, so they are your class 3 levers. I hope you understood, isn't it? So now let me recall the things. In class 1 lever, mechanical advantage can be equal to 1. Mechanical advantage can be less than 1. Mechanical advantage can be greater than 1, isn't it? Similarly, velocity ratio of class 1 lever can be 1. Velocity ratio of class 1 lever can be smaller than 1, and velocity ratio can be greater than 1. Class 2 lever. Class 2 lever ma chai mechanical advantage is always greater than 1. Okay, because here effort arm is always greater than load arm in class 2 lever, whereas in class 1 lever effort arm may be equal to load arm, may be greater than load arm, or may be smaller than load arm depending on the position of the fulcrum, isn't it? Because fulcrum tells you the length of the effort arm and the load arm. Alright, and in class 3 levers, mechanical advantage is always less than 1 because your effort arm is always less than load arm in class 3 lever. Alright, so class 1 lever can be used as a speed multiplier or a force multiplier. Class 2 lever can be used only as a force multiplier, whereas class 3 lever can be used only as a speed multiplier. So why? You know the reason. Why is this condition here? Because you know the reason here. So similarly, in class 2 lever, velocity ratio is always greater than 1, and in class 3 lever, velocity ratio is always smaller than 1. So you know the reasons also. So what are you supposed to know from here is examples also. Examples of class 1 lever, examples of class 2 lever, and examples of class 3 levers. Now you are well aware how you can categorize the different classes of levers. How do you do? By the position of load, effort, and fulcrum. So if fulcrum lies in between load and effort, it is class 1 lever. If load lies in between fulcrum and effort, that is class 2 levers. Okay, and if effort lies in between fulcrum and load, then that class of lever is called as class 3 levers. All right, so that's all from this unit. Now the last and a very important thing that you must remember from here is the examples of each class of lever which are found in our human body. Okay, so class 1 lever is found in our on our body, that is nodding of our head. So when we nod our head, nod our head, so if this is my head, and if this is my chin, are you getting my point? And if this is my neck, are you getting my point? I'm nodding my head, means my first I will push my head up, isn't it? So here this is my effort, and my chin will go up, that is my load, and here the muscles on the neck is helping me to turn the head, nod the head, isn't it? So that is my fulcrum. So here you see fulcrum is lying between load and effort. If I draw a plane here, so my class 1 lever is nodding of head. And class 2 lever. Class 2 lever is your trying to stand on your toes. So if this is my feet, or you can say foot here, these are my toes. I'm trying to stand on my toes. Are you getting my point? So this will be the point through which my body will, or my toes will, what? Rotate, isn't it? Yes, heels will be going up, so that is my effort. And the muscles which are present here is the load. So here you see that load is lying between effort and fulcrum. So this is my second class lever. So what is the example here? Raising the weight of our body on the toes is an example of class 2 lever, which is found in our human body. The third one, class 3 lever. Class 3 lever is raising a load which is kept on our palm. So if this is my, don't look and judge my pictures here. So here this is my arm, I have a load here, so this is my load. Are you getting my point? So these are the muscles which are present here, which is helping me to lift this load. So this is the effort which is applied by my hand, and this is my elbow, and the joint of this elbow is helping me to turn my hand. So that is my fulcrum. So here you see that effort is lying between load and fulcrum. So this is my example of class 3 levers. All right, so these are the 3 classes of levers which you can find in our body. The first one is class 1 lever, that is nodding, nodding of head. Second one is standing on toes, and third one is raising the load on palm. So these are the 3 examples where you can see that the classes of lever can be compared with the parts of our human body. All right, so that's all for today. Thank you.